Another example of a random experiment can be tossing of two coins simultaneously. Tossing of two coins simultaneously. Now, when I toss two coins simultaneously, right, on my two hands, I have two coins and I toss them simultaneously. So, what are the possible results that I get? Let head be denoted by H, and tails be denoted by T. So, what are the possible results? The possible results are, in both the coins, you can get heads, right? You can get head in the first coin, tail in the second coin. This is another result, right? You can get tail in the first coin, head in the second coin, or you can get tail in both the coins, right? Any other possibility? No.
No, sir.
Okay. This is one. Let's say if I toss three coins simultaneously, what can be the outcomes? The possible results when three coins are tossed simultaneously. Are, what can be the results? In all three, you can get heads.
So HHH
You
or
can get
HTT.
two heads, and third coin you can get a tail. You can get
Yes, sir.
second coin, you can get a tail, right? In the
Yes,
first
sir.
coin, you can get a tail, right? Next, what is the next result? You can get tail in the second, third coin. You can get tail in the um,
The tail in the first coin and
first and fourth coin. You can get, right,
yes, sir.
and you can get tail in the first two coins, right? And what else?
Sir,
You
you
can get
can
all
get
tails,
tails. Yes.
right? So what do you see? So what do you see? How many outcomes have I got? Number of results or
Sir,
outcomes?
8, sir.
8. How am I getting this 8 here? See, in each coin, you have two results, right? Head or tail. And how many coins am I tossing? 3 coins. This is equal to 2 cube. Understood? Number
Yes,
of
sir.
results. In this case, if how many results are we getting here? How many results? 4 results only.
8.
Because head and tail are the two results, and we are tossing 2 coins. So we're getting 2 square, which is
Yes.
equal to 4. Okay? This is way you should remember. Okay, and the
So,
last
but we are
example.
tossing the 3 coins.
We are tossing 3 coins simultaneously.
Yes, sir.
So, and the last example is casting of two unbiased dice simultaneously. Two unbiased dice simultaneously. Now, instead of a single dice, if I cast two unbiased dice, what are the results? The possible results are, what can you get? In both the
So,
dice, you
1
can
or
get 1,
2.
1. You can get 1, 2.
Yes, sir.
You can get 1, 3. You can get 1, 4. You can get 1, 5. You can get 1, 6, right? Next, you can get 2, 1, 2, 2, 2, 3, 2, 4, 5, 2, 6, right? Next you can get 3, 1, 3, 2, 3, 3, 3, 4, 3, 5, 3, 6. Next you can get 4, 1. Now because I'm starting here, okay, this is just a starting example. I'm writing all the results. Later on, if I'm doing any problem on casting of 2 dice, I'll not write all the results. You must be able to write all the results yourself. Okay. You can get 5, 1, 5, 2, 5, 3, 5, 4, 5, 5, 5, 6. And finally, you can get 6, 1, 6, 2, 6, 3, 6, 4, 6, 5, and 6, 6. These are the results. Now, if I ask you how many results, number of possible results,
So 36.
is equal to 36. How 36? Because on each dice you have 6 faces, right? You can get either of the 6 outcomes or results, right? And how many dice you are casting? 2. So number of possible results is 6 square. Just as you have, see here, you had 2 results, right? Either head or tail, and number of coins I was tossing was 3. Similarly here, number of results was 6, and number of dice that I was casting was 2. So 6 square. Clear? Remember these. Okay. We'll be using these. Okay. So once we know this, we now come to the next definition of something called as the outcome. Each result of a random experiment is called an outcome. Okay. What do you mean by each result? For example, let us say, going back to this, in tossing of a fair coin, what is this? Head and tail are the possible outcomes. So head will be called an outcome. Tail will be called also an outcome. Okay. So in the casting of an unbiased dice, we're getting this 1 or 2 or 3 or 4 or 5 or 6. 1 is an outcome. Okay. This is an outcome. This is also an outcome. Okay. So each one is an outcome. Each result is called an outcome. Okay. Similarly, in the tossing of 2 coins, this we are getting headed in both the coins. This head is an outcome. This HT is an outcome. Tail head is an outcome. Tail is an outcome. Okay. Similarly, 3 coins are tossed. This is an outcome. This is also an outcome. This is also an outcome, and so on. Okay. In the casting of 2 unbiased dice, each one is an outcome. 1, 1 is an outcome. 1, 2 is an outcome. 1, 3 is an outcome, and so on. Okay. Fine. So once we know outcome, we'll now define a very important definition, which is called the sample space. Okay. The set of all possible outcomes. You have done sets, right? That set, the set of all possible outcomes, is called a sample space. It is denoted by S. Look at the first one. First example. In the tossing of a fair coin. In the tossing of a fair coin, the set S is what? What are the outcomes can you get? Either you can get a head or you can get a tail. So this forms a set, right? The set of all possible outcomes. Any other outcome that you can say in the in the tossing of a fair coin? No.
No, sir.
Next example, let us take this. Casting of an unbiased dice. What is S?
So
Either one,
1, 2, 3, 4, 5, 6.
right? This is S. You can get any of the results. The set of all possible outcomes of a random experiment. Okay, that completes the definition. Okay, and finally, in um, not finally, but the third example, a tossing of two coins simultaneously. In the tossing of two coins simultaneously. What is the set S? HH, HT, TH, and TT, right? In the tossing of three coins simultaneously. What is the sample space? All heads, right? All the 8 outcomes, right? Right? And finally, in the casting of two unbiased dice simultaneously. What is the sample space? 1, 1, 1, 2, 1, 3, and you can continue this way till 6, 6. Right? All the results I have written above. Now, uh, you know how to write the sample set, but suppose if I give you a pack of 52 cards, and if I ask you what is the sample space in this case, can you actually write the sample space in case of cards? Can you write? What are the possible outcomes? Suppose from a pack of cards, you're drawing out a single card, any one card you're drawing. Can you write down the sample space? Is it possible?
So
Tell
if
me.
you are taking out
Hmm,
any one card,
hmm. If you're taking out one card from a pack of 52 cards, okay.
so then all the cards we could write, sir.
Yes, but how will
Yes,
you
sir.
write? How will you write? How will you write the sample space S? Will you write S is equal to, you know, ace of hearts and let's say king of diamonds? Are you going to
Yes,
write all
sir.
this? No, it is not
Yes, sir.
written in this manner. Okay. So in the case of your uh, drawing out a pack of cards, we normally don't write the sample space. Okay. We only write the uh, number of possible outcomes. Okay. How many possible outcomes when I'm drawing out a single card from pack of 52 cards?
52.
So 52.
52, because we can get any of the 52 cards, right? So in case of cards, normally we don't write the sample space. Okay. Okay. Now, once we know the definition of sample space, now we are in a position to define something called as the event. Very important definition. Event. Any subset of the sample space is called an event. of the sample space. I've written all the sample spaces above. You see, each of the experiment is called an event. This is the mathematical definition. The normal definition is, you can also define it this manner: any particular outcome or a collection of outcomes. Collection of outcomes is called an event. Okay, very important definition. For the time being, you can remember the first definition. Any subset of the sample space is called an event. Okay. Okay, now the examples for events. Okay, in the casting of a fair dice or an unbiased dice, in the casting of an unbiased dice, sample space is this, right? Now, if I define the event, let E be the event. Okay. Appearance of an even number. Right? If I define this event E as appearance of an even number, then what is E? E is what set? Either you can get a 2 or a 4 or a 6, right? So this is what you see. Each one here is an outcome, right? Each one here is an outcome. And what do you see? You're getting what? 2, you're getting a collection of outcomes, 2, 4, and 6. So here is a collection of outcomes. So any particular, even one outcome is called, may be called an event, or a collection of outcomes can also be called an event. Clear? Is it clear?
Yes, sir.
I'll give you
Yes,
more
sir.
examples. Also, what you must see is that this is nothing but a subset of the sample space. Okay. This is one example. Let us say on the same set, if I define the event, let's call this event E1. E1. Okay. Let us define E2 as the event appearance of an odd number. Then what will be your E2?
So 1, 3, and 5.
1, 3, 5. Which is again a subset of the sample space, right? So what you see here is that each event that you get is a subset of a sample space. Okay. Let us define another event, last one. Let E3 be an event. Appearance of an even prime.
So, sir, each event is a subset.
Yes. Every event is a subset
Okay, sir. Okay, sir.
of the sample space. Okay. So E3, what is the event here? Appearance of an even prime. And what is the only even prime here?
So 2.
2. So you see here, this is a set which contains only one element. That means 2 was an outcome, and you have an event which is which contains only a single outcome, right? So event can either be a single outcome or a collection of outcomes. Okay. Okay, so we'll discuss this more in detail about events. Let me give you uh, an example from. Let me give you the formula for probability first. Okay, the formula for probability. How to calculate probability and how to use it. I'll just give you a small example. Then we'll proceed with the problem from the textbook. Okay. The formula for probability. If E be any event, defined on a sample space S, then the probability of the event E is written as PE, probability of the event E, or written as PE, okay, is equal to number of outcomes favorable to the event E. I will see what this means, divided by number of outcomes, total number of possible outcomes. Okay. Now, to give you a small example, look at this example that I've given you. This one, in the casting of an unbiased dice. What was E1 here? E1 was appearance of an even number, right? And what is this? E1, 2, 4, and 6. So in this case, if you see, what are the number of events, number of outcomes favorable to E1? What are the outcomes favorable to E1? How many events in E1? 3, right? And how many total number of possible outcomes?
6.
6, because the sample space contains how many events? How many outcomes? 6. Total number of possible outcomes is 6. Therefore, what is the probability of E1? It is, what is the formula? Number of outcomes favorable to E, favorable to E1, divided by total number of possible outcomes, right? That was the formula. Which is equal to how many outcomes favorable? 3. How many total? 6. 3 by 6, which is equal to half. So the probability of the event E1, that is probability of appearance of an even number, is only half. Similarly, can you calculate the probability of E2? The event
Yes, sir.
E2, tell me. Probability of E2, PE2. What is the probability of this event E2? Tell me.
So the number of outcomes are for E2 are
Favorable outcomes. Number of favorable outcomes in
so the
numerator. How many?
favorable outcomes for E2 are 3,
3. And total number of possible
and
outcomes?
the total number of possible outcomes are 6.
6. So again, this is half, right? Let us say E3. If you have to calculate the probability of E3, how will you calculate? How many now outcomes favorable to the event?
So one,
Only
sir.
one. Only one. And total
Yes,
number
sir.
of possible outcomes is 6. So probability is 1
6.
by 6. Okay. That is how you calculate the probability. And I have given you a very simple example. We'll have further examples when we proceed with the problem from the textbook. Okay. So I'll stop here.